List various types of surge arresters: root gap arrestor, horn gap arrestor, sphere gap arrestor, multi gap arrestor, expulsion type arrestor, electrolytic type arrestor, lead oxide type arrestor, thyroid type arrestor or valve type arrestor.
Give the brief details of rod type lightning arrestor. So, this type of lightning arrestor has the simple construction. Two rods of 15 mm diameter are bent at the right angle and kept such that the gap remains between two rods like this. These two rods are kept bent at right angle, either like this or like this. So either type of construction is possible. This is for transformer protection case. This is for transmission line protection case. The distance P between the insulator and gap should be more than 1/3 of the length of this insulator, 1/3 of this insulator, so that the arc occurs away from the insulator when arc occurs. So the arc takes place between these two electrodes, between this gap, and it is safe away from the insulator disc over here. The length of the gap is kept such that the breakdown occurs at the 80% value of the spark over voltage, so that the steep wave front cannot come or does not come on this insulator disc, and this is how this rod gap protects against the lightning surges.
Give the constructional details of rod type arrestor. So it requires metal rods. Two metal rods, often made of either copper or aluminum, are placed parallel to one another at a predetermined distance apart, having a small gap in between. The mounting structure: to maintain electrical isolation from the surrounding environment, the rods are supported by an insulating mounting framework, which is often composed of either porcelain or polymer materials. Air gap: between the two metal rods, a small air gap is maintained at a specified distance, that is, the distance P should be greater than 1/3 of the total length of the insulator string. This gap is critical because it controls the voltage at which the arrestor discharges to the ground. Connecting hardware: so connectors and fittings are needed to connect the arrestor to the electrical systems that it is designed to protect. So these are some constructional details of rod type arrestor.
State the advantages of rod type lightning arresters. So it comprises of a single metal rod connected to the ground, making it easy to install and maintain. No moving part or complex components are there, so it reduces the chances of failure. Less expensive compared to other types of surge arresters. It provides a direct path for lightning currents to safely discharge into the ground. Since it is not directly connected to the power system, there are no energy losses during its normal operation. It made from corrosion resistant material, ensuring longevity and withstands extreme weather conditions like heavy rain, storms, and strong winds. It does not require hazardous materials or chemicals, so making it safe for the environment. So these are several advantages of rod type lightning arresters. State the limitations of rod type lightning arrestor. So rod type lightning arrestor is one of the simplest method of protection and the oldest method of protection. A rod type arrestor primarily protects a conical area defined by the 45-degree angle rule. So if structures or equipment are outside this zone, they remain vulnerable to lightning strikes. Means it provides limited protection. It only protects against direct lightning strikes but does not safeguard against induced surge caused by the nearby strikes. Poor grounding can lead to side flashes, electrical hazards, or even fire risks. Arc is maintained even after the surge is suppressed and the normal voltage is restored. This causes the short circuit in the system. Single rod are insufficient for protecting large or complex structures like industrial plants, transmission towers, or substations. Corrosion, mechanical damage, and poor installation can reduce the efficiency over the time. Rod can melt due to the heat of the arc. So these are some limitations of rod type lightning arrestor. The constructional detail of sphere gap type arrestor. So sphere gap type arrestor consists metallic spheres that are treated as electrodes. The arrestor consists of two highly conductive metallic spheres made up of copper, brass or aluminum placed at a fixed distance apart, which creates an air gap. So second component is gap spacing or air gap. The distance between two spheres is carefully calculated to allow for normal system voltage to be sustained. When a high voltage transient appears, the air gap breaks down, creating an arc discharge path from that line to earth or ground. So it is air gap only. So no material specific detail is required because the air itself is an insulating medium or a conducting medium in between. Supporting insulators. The spheres are mounted on high strength insulating material or supports made up of porcelain or polymer material or insulators to ensure electrical isolations from the ground and the supporting structure. Connection terminals. The arrestor is connected between the line, that is phase conductor, and ground to divert surge safely from line to earth. Choke coil. It consists of high inductive winding made from copper or aluminum wire wound on a metallic core, that is of iron or ferrite core. The size and inductance of the choke coil depend on the system voltage and the expected surge conditions. So these are some constructional details of sphere gap type arrestor. We have already seen the diagram for the same while we are discussing the brief operational detail of sphere gap type arrestor. Explain working of sphere gap lightning arrestor in brief. So in this, two metal spheres are kept near to each other at a relatively small distance or a certain small distance. This will cause a sphere gap in between these two spheres. Sphere A is connected with the line and B is connected to the earth. One choke coil is placed in between phase B of the transformer and sphere A so that the overvoltage surge does not go to the winding of the transformer after the reflection like this. There is no discharge at normal voltage in the healthy condition. The air between the spheres breaks down and the arc is produced between these spheres when the overvoltage occurs or comes. The arc goes up to the heat, arc continues at the normal voltage and it stops when the voltage is not available when the circuit breaker is tripped. So without the tripping of circuit breaker, the arc does not quench in this type of arrest. State the advantages of sphere gap lightning arrestor. So there are several advantages of this kind of lightning arrestor, but some of them listed over here. Consists of two metallic spheres with an air gap, making it easy to construct and install. Less expensive compared to more advanced surge arrestors. Operates quickly when a voltage surge exceeds the breakdown voltage of the air gap, providing immediate protection. Functions only during the overvoltage conditions or surge conditions, ensuring there is no continuous power loss in the systems. It can handle high magnitude lightning surges efficiently by discharging the excess energy safely to the ground. After a surge, the air gap returns to its normal state, making the arrestor ready for the next event without needing replacement. Used in substation and transmission lines where high voltage protection is required, it is meant for the high voltage over voltage surges only. So these are some advantages of sphere gap lightning arrestor. State the disadvantages of sphere gap lightning arrestor. So there are several disadvantages of sphere gap lightning arrestor. Some of are listed over here and explain. The operation of the arrestor depends on environmental factors such as temperature, humidity, and air pressure, which can affect the breakdown voltage and its reliability. Unlike modern arresters, sphere gap arresters do not provide precise clamping of voltage, making them less effective in controlling over voltage levels. The electrode surfaces may get oxidized or eroded over time, affecting their performance and requiring periodic cleaning or replacement. While sphere gap arresters can handle direct lightning strikes, their response time is slower than modern semiconductor-based surge protection devices. These arresters are designed mainly for high voltage applications and are not effective in protecting low voltage electrical and electronic components or equipments. When a discharge occurs, the arc between spheres can persist longer than desired, leading to excess energy dissipation and potential damage to the arrestor. After a heavy surge, the gap may need to be manually reset or adjusted, making it less convenient compared to modern self-restoring arresters. So these are several disadvantages of sphere gap lightning arrester.
Give the constructional details of horn type gap arrestor. So in the figure you can see the horn type lightning arrestor. In this a series resistor is connected and a choke coil is placed with transformer in all three phases. The transformer is placed delta started. So horn shaped electrodes means two electrodes or rods typically made up of copper or aluminum are bent in a horn shape and placed facing each other like this. Series resistor, it is optional. A high resistance is often placed in series with the arrestor to limit the follow-through current after the surge is discharged from ground to phase or say ground to line type. So the follow-through is limited with the help of this series resistor. A spark gap. Spark gap, the space between the horn-shaped electrodes acts as a spark gap. Under normal conditions, the gap remains non-conducting. So the medium between these two is air. So no need to specify the material used for it. Insulators. The horns are mounted on a porcelain or a polymer type high strength insulators to provide mechanical support and electrical isolations between the live part and ground part. So it is an electrical isolation. Earth connection. One end of the arrestor is connected to the line conductor or say live conductor, while the other is grounded to safely discharge the excessive voltage surges. So these are some constructional details of horn type lightning arrestor.
Explain.
Working of horn gap lightning arrestor in brief. So under the normal operating voltage, the air gap between the horn-shaped electrodes remains non-conducting. No current flows through the arrestor and it does not interfere with the power system. When a surge occurs, the voltage across the air gap increases. If the voltage exceeds the breakdown strength of the air gap, the air ionizes and an arc forms between the electrodes. The surge current is diverted safely to the ground from the live part. The arc formed between the horns is pushed upward due to the electromagnetic force and thermal convection properties. As the arc moves along the diverging horns, it lengthens and cools down. Eventually, the arc is extinguished and the system returns to its normal operating condition. An inductor is connected between the winding of the transformer and horn, which gives negligible reactance at the power frequency but offers high reactance to the overvoltage due to the high frequency. So the overvoltage does not affect the winding of the transformer and is grounded through the horn gap. Resistance is also connected in series with the horn to limit the follow current. So this is how horn gap lightning arrestor works.
State the advantages of horn gap lightning arrestor. So there are several advantages. Few of some are listed here.
It has a simple design with minimal components, making it cost effective compared to other types of lightning arresters. After discharging a surge, the arc automatically extinguishes, restoring the system to its normal operating condition without any manual intervention. Requires least maintenance as it has no moving part and operates without any complex electronic components. It is well suited for medium voltage outdoor distribution systems, transmission lines and substations. The diverging horn-shaped electrodes facilitate natural arc extension by stretching and cooling the arc. Magnitude of the follow current decreases due to the series resistance. Unlike some other protective devices, it does not draw power from the system during its normal operating condition. It provides adequate protection against lightning and switching surges by safely directing the excessive voltage to the ground. So these are some advantages of horn gap lightning arrestor.
State the disadvantages of horn gap lightning arresters. So there are several disadvantages of horn gap lightning arrestor compared to other type of arresters. So some of are listed over here and we are discussing in brief. It may not effectively handle very fast transient surges such as those caused by the switching operation in modern day power systems, because in modern day power system we are very much utilizing power electronic devices which are acting very fast and which has very high switching speed. The performance and setting of the horn can be affected by humidity, rain, dust, corrosion, pitting and pollution, which may alter the breakdown voltage of the air gap. Compared to the modern metal oxide varistors, MOVs, horn gap arresters have a slower response to transient over voltages, and the operating time of this type of arrestor is nearly 3 seconds, which is very high. The gap between the horns must be adjusted carefully to ensure reliable operation, making its installation and maintenance more challenging. It is generally used in medium voltage and high voltage applications, but is not effective for protecting sensitive low voltage electronic devices. Frequent operation may erode the horn electrodes, reducing the arrestor's lifespan and requiring periodic maintenance. Horns can get shorted by the external objects like branch of the trees, wire, some creatures like snakes and all, etc. This will affect the operation and performance of the horn gap lightning arresters. So these are some disadvantages of horn gap lightning arresters.
List out different types of arresters used for multi-gap arresters. So there may be a construction type of rod gap arrestor, horn type gap arrestor, impulse gap arrestor, resistance graded arrestor, electrolytic arrestor. Nowadays it is obsoleted. Multi-chamber arresters. So these are some of type of arresters used for construction of multi-gap arresters. Give the constructional details of multi-gap lightning arrestor. So there are series of spark gaps. These multi-gaps with 4 or 5 cylinders made up of zinc, copper or aluminum are arranged in a series to increase the breakdown voltage. Resistor or non-linear resistor. So used to control the current flow and prevent excessive power dissipation, we require resistor or non-linear resistors either made up of a semiconducting material or using a carbon resistors. Insulating housing made up of porcelain, glass or polymer to provide insulation and mechanical protection. Electrodes. These electrodes are made up of copper, brass or other conductive materials to ensure proper arcing. Grading rings used in high voltage applications to maintain uniform voltage distribution across the gaps. Arc quenching mechanism. Some design include magnetic blowout coil or cooling chambers to extinguish the arc effectively. And the spark gap, which is made up of only an air gap. So this type of materials are used for construction of the multi-gap lightning arrestor against the protection of lightning and switching surges.
Brief about Functioning of multi-gap lightning arrestor. So the first electrode is connected to the line and the last is connected to the earth through a series resistor to reduce the follow current and power arc. But by doing so, means connecting the series resistor, the protection against the traveling wave is reduced. To prevent this, a shunt resistor is connected across cylinder number 3 and cylinder number 5 that we have already seen in the previous figures like this. This we have already seen, that is a shunt resistance is connected across this gap 3 and 5 and series resistance is connected like this. So in normal healthy condition, cylinder number 3 is at the earth potential through shunt resistance and series resistance R. So normal supply voltage is not enough to cause breakdown of the series gap, but in case of over voltage, breakdown occurs between cylinder 1 to 3. Current produced due to the breakdown prefers the straight path through the cylinders 3, 4 and 5 instead of passing through shunt resistance like this. Instead of passing through this shunt resistance, the current flows in this direction because it offers a low resistance path to the arc. So current flows in this direction from line to earth with the help of this series resistance. So current produced due to the breakdown prefer the straight path through the cylinders. The arc produced across cylinder 3, 4 and 5 quenches when the surge suppresses, and the power will be limited by shunt and series resistance. This current is insufficient to maintain the arc in the gap 1, 2, 3 and the normal condition is restored. This is how multi-gap lightning arrestor functions at the time of switching surge or lightning surge.
State the advantages of multi-gap lightning arrestors. So it increases the breakdown voltage and making it suitable for high voltages. Effectively diverts high voltage surges and protects electrical equipment to which it is connected. In resistance graded arrestors, resistors ensures uniform voltage distribution across each gap, reducing stress on any individual gap. After diverting a surge, the arrestor returns to its non-conducting state automatically, ensuring continuous protection and make the lightning arrestor ready for the another operation. So now designed for repeated operation without significant wear and tear, making it more durable than single gap arrestors. Some designs, that is horn gap or multi-chamber arrestors, facilitate quick arc extinction, reducing damage to the arrestor. It can be used for low, medium or high voltage systems, making it versatile. Multi-gap arrestors have simple design and require minimum maintenance. So these are some advantages of multi-gap lightning arrestors.
Take the disadvantages of multi-gap lightning arrestors. So there are several disadvantages of multi-gap lightning arrestor. Like the voltage across the arrestor during operation can be high, potentially stressing the insulation of connected equipment. Voltage may not be evenly distributed across all gaps, leading to premature breakdown of some gaps. Once the gaps ionize, it can be challenging to extinguish the arc, especially in high energy surges. Some designs may not effectively clear carbonization or debris after repeated operations, requiring maintenance or replacement. Multi-gap arrestors tend to be larger and heavier, making installation more cumbersome. Humidity, dust, and pollution can impact the effectiveness of this kind of air gaps or lightning arresters performance. Multi-gap arrestors have largely been replaced by metal oxide arrestors, which offer better performance, faster response, and lower maintenance requirements. So these are several disadvantages of multi-gap lightning arrestor.
Explain construction of expulsion type arrestor or protector tube. So as per the figure, you can see the constructional details or actual position of protector tube. A series spark gap is available. So a series spark gap is placed in series with the arrestor like this with the arrestor. It prevents leakage current under normal operating conditions. A tube. or expulsion chamber like this. Tube is connected. A fiber or organic material lined tube that serves as the expulsion chamber. When an arc occurs inside the tube, the heat causes the inner lining to vaporize, means it produces or hitting the inner chambers or inner walls of the chamber, producing gases that assist the extinguishing the arc. Metallic electrodes. These metallic electrodes are connected on either sides. It is positioned at both the ends of the arrestor to provide electrical connection points. The tube is kept such that the top electrode is connected with an air gap comes directly below to the line conductor, whereas the lower electrode is joined to the earth like this. This is the top electrode and the lower electrode is connected with the earth. They help initiate and sustain the arc before it quenches. Insulating housing. The arrestor is enclosed in a weatherproof insulating housing made of either porcelain or polymer for mechanical protection and electrical insulations. So these are some basic constructional details of expulsion type arrestor or protector tube. Explain the working of expulsion type arrestor or protector tube type arrestor. So under the normal voltage condition, the arrestor remains inactive, means it is not in active state or not in conducting mode. So no current flows through it. But when a high voltage surge appears on the electrical system, the potential difference like this potential difference across the series gap increases. Once the voltage exceeds a critical level, the air gap between these two breaks down, allowing the surge current to pass. So surge current will pass through this gap. The surge current creates an arc inside the tube. This is the inside the tube. Surge current creates the arc inside the tube. The arc hits and vaporizes the quenching material. This is the inner wall of the protected tube, producing gases like water vapor and carbon dioxide. This gas comes out through the lower electrode like this, the lower electrode. So rapidly, and lower electrode expands rapidly. So the ionized air surrounding the arc goes out like this, blowing out the arc and extinguishing it. The arc is quenched at the current zero interval and does not restrike. Means arc does not restrike again. After the surge is discharged, the series gap regains its insulation property and arrestor remains in the previous state, which is under normal voltage condition like inactive or not in working state. So this is how expulsion type or protector tube type arrestor works. State the advantages of expulsion type arrestor or protector tube. So there are several advantages. Some of are listed over here. Once the surge is discharged, the arrestor automatically resets itself without requiring manual intervention. It is relatively inexpensive due to its simple construction and readily available materials, so it is cost effective. The expulsion process rapidly extinguishes the arc, preventing damage to the system or equipment or the operating personnel. It effectively discharges high voltage surges, protecting electrical equipment. There is no power frequency follow current, means back current. Easier to install and maintain compared to other heavy duty arrestors. Unlike valve type arrestors, it does not allow leakage current under normal operating conditions. Commonly used in the distribution networks up to 33 kV, so it is highly recommended or suitable for the medium voltage system. So these are several advantages of expulsion type arrestor. State the disadvantages of expulsion type arrestor or protector tube. So when it operates, it releases gases and can be hazardous in enclosed spaces. They are ineffective against high frequency transients. The internal components degrade over time due to repeated exposure to the surges, requiring maintenance or replacement. These arrestors can only operate once per surge event. So after the operation, they need to be replaced or serviced. Unlike modern MOV metal oxide varistors, this type of arresters, expulsion type arresters, do not self-restore after a surge event. Voltage current characteristic is not proper of this type of arrestor, so it is not useful for the costly equipments. The expulsion process can create mechanical stress on nearby equipment due to the sudden release of energy. It is useful up to 33 kilovolt system is medium voltage distribution system. So these are several disadvantages of expulsion type arrestor. Explain construction of electrolytic type arrestor. So as you can see in this figure, it is an early form of surge arrestor used to protect the electrical equipment from transient over voltages due to lightning surge as well as switching surge. So it is used like electrolytic cell. So the electrolyte is typically a weak acidic or alkaline solution which acts as a resistive path to control the flow of surge current. Aluminum or lead electrode like this is the main electrode. So in this, a thin film of aluminum hydroxide is deposited on a thin plate of aluminum. This plate kept in electrolyte. Porous insulating material around it. This material provides insulation under normal operating conditions and allows conduction during the surges. Series resistance. So a high resistance element is connected in series with these electrodes. This limits the normal leakage current but allows the high currents during surges. Series gap or spark gap. You can see this two horn gap the above, and this is porcelain bushings connected. This is metallic cover. This is welded steel tank. Oil is filled in this. Copper connector like this here it is connected. This is insulation tube. This is wooden support. Oil is again filled in this. Electrolyte is placed. See cones in cross section. These cones are placed one over another. Aluminum cones complete here like this. This is aluminum cones completed. Centering contact spring. This is and metal base. This is the downward. This is the metal base. So this is how this arrestor is constructed. Spark gap is placed in some designs to help initiate the conduction during a surge. So this is how electrolytic type arrestor is constructed. Explain working of electrolytic type arrestor. So in the figure you can see the construction of electrolytic type arrestor. Under normal operating voltage, the arrestor remains in a non-conducting state due to the high resistance of the electrolyte. But when a surge occurs, the high voltage causes ionization of this electrolyte, reducing its resistance significantly to a low value. The film of aluminum hydroxide gets punctured at over voltage and low resistance path is available or offered. This allows the excessive energy to be safely discharged to the ground. Once the surge subsided, the resistance of the electrolyte increases again, restoring to its normal operation of the system and the high value of the resistance. There is a critical voltage for the film to puncture. In this, some cells are stacked above. These are some cells stacked one above the other. If the number of cells are n, then the total critical voltage is equals to critical voltage of each cell multiplied by number of cells, that is n. Thus, the number of cells are used depending upon the voltage. When the voltage increases, the number of cells must be increased accordingly. So this is how the electrolytic type arrestor works. State the advantages of electrolytic type arrestor. So there are several advantages of this electrolytic type arrestor. Some of are listed over here. So it can handle high energy surges effectively, making it suitable for early power system protection. The resistance of the electrolytic increases back to its normal after a surge, allowing the arrestor to be reused without replacement. There is no need of the series resistance in this case. The design is relatively simple with fewer mechanical parts, making it easy to manufacture. It functions without the need for external controls as it responds to voltage surges automatically. It provides good protection against lightning and switching surges in early electrical systems. At the time of its use, it was an economical solution for overvoltage protection. Its discharging capacity is high. So, these are several advantages of electrolytic type arrestor. State the disadvantages of electrolytic type arrestor. So, there are several disadvantages as these were some ancient type of arrestor which were used in early days. So, compared to the modern arrestors, it has a slower reaction to transient surges. The electrolyte degrades over the time, requiring regular maintenance or replacement. The repeated exposure to surges affects the electrolyte and electrodes, reducing the arrestor's effectiveness over the time. This electrolyte solution can evaporate over time or freeze in the extremely cold conditions, reducing its effectiveness, and operation of the arrestor is at stake. It cannot effectively handle extreme overvoltage conditions in modern high voltage transmission systems, and because of it they are replaced. Compared to the modern metal oxide arrestors or MOVs, electrolytic type arrestors are larger, less efficient, and have been phased out in favor of better alternatives. Even under normal operating conditions, there is a small leakage current through the electrolyte, which can lead to energy losses and heating during its operation. So these are several disadvantages of electrolytic type arrestor. Explain the construction of lead oxide type arrestor. So this type of lightning arrestor is in the form of separate discs, which are stacked one over the other. Number of cells depends upon the normal system voltage. Housing, that is casing made up of polymer or porcelain material, provides mechanical strength and insulation alongside protection against environmental conditions like moisture and dust. It has venting arrangements to release pressure during these faults. The core component made up of lead oxide, this lead oxide mixed with other metal oxides. It exhibits non-linear voltage current characteristics, that is high resistance under normal condition and low resistance during surges. It converts excess surge energy into heat and dissipates it safely into the environment. Series gap assembly made up of air gaps. So this you can see here, this series gap assembly made up of air gap is in series with the lead oxide disc. Normally it acts as an open circuit, means offering high value of resistance in series. In this, there are two circular electrodes of iron, one side of which there is a coating of varnish. Sealing arrangements prevents ingress of moisture and contaminants and ensures long-term reliability of the arrestor. Explain working of lead oxide type arrestor. So under the normal operating voltage, the lead oxide disc, that is non-linear resistors, exhibits a very high resistance. The series gap assembly remains an open circuit and preventing the current flow through its arrestor. The power system operates normally without any leakage current through the arrestor during this normal operating voltage condition. Now, when a high voltage surge appears on the power line, the voltage across the arrestor increases. The series gap assembly breaks down, means ionizes and becomes conductive. The lead oxide disc exhibits a low resistance at high voltages, allowing the surge current to flow through the arrestor. The surge is safely discharged to ground, protecting the connected equipment. Lead peroxide is a good conductor of electricity at the room temperature, but at about 150 degrees Celsius temperature, it becomes the insulator because it is converted into lead tetroxide when it is heated. The coating of varnish breaks down due to this overvoltage and discharge occurs from the lead peroxide. Lead peroxide is converted into red lead due to the heat produced due to passage of current. Discharge stops due to the high resistance of the red lead. Size of the cell is kept such that it can last for certain number of years. Cell becomes useless when all the lead peroxide is converted into red lead. Once the surge energy is dissipated, the system voltage returns to its normal value. The lead oxide dish regains its insulating property, that is high resistance, preventing further current flow during the normal operating condition after the surge. The series gap deionizes, restoring its insulating properties. The arrestor is ready for the next surge event. So this is how the lead oxide type arrestor works.
State advantages of lead oxide type arrestor. So there are several advantages of lead oxide type arrestor. Some of are listed over here. Lead oxide dish exhibits high resistance under normal condition and low resistance during these surges, ensuring efficient protection. It reacts quickly to overvoltage surges, providing instant protection to electrical equipment. After discharging the surge, it automatically returns to its high resistance state, making it reusable without manual intervention or resetting. It protects electrical power systems from lightning strikes, switching surges, and transient overvoltages. It is made from robust materials like porcelain housing and lead oxide resistors, ensuring a long operational life. It requires minimal maintenance as it does not degrade easily under normal conditions. It does not require day-to-day care and maintenance. Comparatively cheaper than other metal oxide arresters, making it a viable option for medium voltage systems. It is especially useful for remote locations. First, the breakdown of varnish occurs, so there is no effect of low value of transient on the operation. So these are several advantages of lead oxide type arrestor.
State the disadvantages of lead oxide type arrestor. So there are several disadvantages of this type of arrestor. Some of are listed over here. Lead oxide arrestors tend to degrade over the time due to the moisture absorption and thermal cycling, reducing their effectiveness. They exhibit relatively high leakage currents, leading to increased power loss and heatings. Their performance is less stable compared to modern metal oxide arrestors (MOVs), especially under repeated surge conditions. They have a limited ability to handle high energy surges, making them less suitable for high voltage applications. Due to aging and material properties, they require frequent inspection and maintenance. The response time to transient overvoltage is slower compared to modern zinc oxide arrestors, making them less effective in high-speed transient protection. Lead oxide arrestors are generally larger and heavier than modern alternatives, making installation and handling more difficult. So these are several disadvantages of lead oxide type arrestor.